which I just send you so you can experience. And I assume everybody knows this truth. The idea is that there's a difference between the way that you process um, congruent and incongruent stimuli when you when there's a word that does not fit its color. It's easier to um, and it's difficult to identify. It's more difficult to identify than a word that does fit its color. And Ronen is a lot more of an expert on this than I am. And I just let you try a very basic Stroop task. And what I want to do right now is go over the code for the Stroop task that you just ran, and see how such a complex task may be programmed. Now, before we go into the code, I want to take the time to think about the design, about how you would go about building such a task. What do you want? What do you want to perform? And I find a lot of times that, at least when I go, when I have a task in mind, I start to program it, and then I say, wait. Before I go to the code, I need to stop and have a full design of what I want to happen and at what stages and so on. And before we go into the code, that's what I want to do. So, okay, so I have a problem with my animations. So we'll just put it all out like this. So this is how a single Stroop trial works. At the beginning, we want to show a fixation. Then we want to first hide the fixation, then show the target, the word that we want to show, then listen for response and listen for responses. After a while, we want to hide the target, so the person needs to has only a certain exposure to the target. Then maybe before, maybe after we had the target, we want either to score the response or to warn that the time has passed and the person can't respond to that anymore. And finally, we want to end the trial. So a task that seems really simple turns out to have a lot of steps on the way, and we need to count to each of them. This is why many times Minno time tasks become very long. It can be hundreds of lines of code because they tend to be really complex, and there's no way to deal with complexity except for dealing with it, for having the whole design. We can't guess what you intend or what you need to do. So these are the steps, and we want to keep them in mind when we read the program itself. Then we have the question of randomization. What do we want the randomization to look like? So we're doing only 12 trials of Stroop. It's not really difficult to make more, but 12 is short enough that we can run it really quickly and see what goes on. And we have 3 types of trials: congruent, incongruent, and neutral. So we'll have the word red in red, the word red in blue, and then just XXX in red. So it doesn't have a loading of the word. And we have several, I think, two stimuli of each type. So we want to keep we want an equal number of stimuli of each type appearing. Okay, so this isn't a very complex randomization, but still there are a lot of requirements here, and we'll need to see how we do that. Otherwise, everything is random. We don't know. We don't have a specific order to when the congruent or incongruent or types occur. We might randomly have all four congruent trials appear right at the beginning. We can have specific stimuli appear one after the other. Everything goes. Okay, so let's do this. Let's see how this works. This is the file that we're going to work with. Here, I'll give you the. If you right-click on the file names in the dashboard, you can copy the URL for the file itself. And I'll paste that into chat real quick. So if anyone wants to go through the code at their own pace, you can always do that. There you go. And again, you need to copy this whole link, in order for it to work. If anyone has trouble, let me know. One other thing that I'll say, that the default version of Minno.js in the dashboard right now is version 0.1. Don't use 0.1 unless you're working with old code. Use 0.3. The way to do that right now is using the experiment file and setting it to the 0.3 JSP.
Yeah, so the XPT file in the example in your workshop IIT is fine. That's what we did. So by default, you will run like that example uses version 3. So just if you always base your stuff on that example, it will be fine.
Right? And just know that if you play using the arrow, you get the old version. And most of the time it's fine, but some of the time it isn't. And version 0.1 is significantly less accurate than 0.3. Use 0.3.
Yeah, although if you play from the XPT file, it does know to run the 0.3 version. Because it just, it's the launching. It runs the XPT, and the XPT will activate the 0.3 version.
Okay, so we're going here, and this experiment is very involved. It has about 200 lines of code, and I want to start by reading the main trial, and then go back to see how different things from the context affect it. Okay, so the stimulus trial, whoever's following on line 81, has two parts only. It has interactions, and it has stimuli. The reason that this can work is that we can add inputs dynamically, and that's useful if you don't want participants clicking too early before they even see the stimuli. And we have three stimuli. One is a timeout message. The second is the fixation, and the third is the actual target, the Stroop words. And this is one of the most complex parts of this trial. We'll keep understanding how the target works to the end. and see these stimuli if you want, whatever. And what I want to do is just read through the interactions and see how they build the experience that you had when you ran the study yourselves. So we start the task with showing the fixation. So how does this work? We have a condition type begin. So this triggers as soon as the trial starts. And what it does is show the fixation, and it triggers the show target event at this time. So what do we have here? This is a template. We saw templates yesterday a bit, and it accesses the duration object in current, and it takes the fixation duration out of it. Now, where is this thing? If we go back to the top, we have this section. In this section, we set various variables in our environmental variable. So we have the text for the instructions, and we have an object with durations. Now this is completely arbitrary. When Ronan wrote this, he decided that he needed all the timing in a single place, and just for convenience, he put them all in the same place. So we have so show the fixation for 1,000 milliseconds, and then show the stimulus for half a second, and then give another second for the response time, and then give a second of feedback and a second of intertrial interval. And the big advantage here is all the timings are in one place, and it's very, very easy to tweak them however you want, and to get an idea of what the settings are without running throughout all your code. So this is just a matter of convenience, but in the long run, it has a very big impact on how things work. So what we have is a trigger that creates an event called show target after a specific duration. We know it's a second because that's what it says. It says in in the variable at the top, but it's not. But it's not critical. It's really easy to change. Okay, so so we show the fixation, and after some time, we trigger the show target event. Now, this interaction, the second interaction, is listening to the show target event. If input equals the show target, this will happen. Now, what is going on here? First of all, we hide the fixation. That's important. And we show the target. Next, what we do is create two inputs. One is the blue key input. The second is the red key input, and they get fired when you press the I key or the E key. Okay, these are the three things that we said that needed to be done at the second step. Additionally, we reset the timer. When we log data in Minno.js, it logs how long it took from the beginning of the trial to the moment that the log event happens. And we have an action that allows to reset the 0 point of the timer to the time usually where the participants can start responding. So that's this action. And finally, we add two triggers, two timeouts. One is how long until until there's a full timeout and the participants can't respond anymore. And the other is until the time that we want to hide the stimulus. And then we have an interaction for each of them. So the target out interaction simply hides the target. Very simple interaction with a single condition and a single action. And where's the timeout here? And we have the timeout interaction down here. And what it does is just a bit more involved. Let's get back to it after we see how we respond to specific answers. Okay, so that was quite a lot. Any questions before I go on? I know this is rather quick and a lot to take in. So so please feel free to stop me. Okay, so let's see how we deal with specific responses. So now we run into a new type of condition, and this this condition looks at the input, and the input is the name of the input that we defined above, either blue key or red key, and then compares it to a property of the stimulus called correct. Okay, why would we do that? For that, let's start with take a break from the interactions for a second and go back to the stimuli. And let me present the stimuli in an easier to understand way. Okay, so this is a stimulus, regular stimulus, but as you can see, almost all of its fields are defined using templates. How does this work? This template refers to the trial data. Each element in Minno.js at all, you can use it in MinnoQuest or Minno Manager as well if you want, has an optional field that looks like this. It's called data, and you can put anything you want in this object. And later on, you can use it in templates or in branching or all sorts of things like that to do interesting things. So this stimulus uses data from something like this to build itself. So the actual media that it uses, the actual words, come from a field called text, and the color come from a field called color, and the correct response come from a field called correct. So this is very, very generic, but where do we actually define these values? Where do we create this distinction, and why do we do it? So the why is rather easy. If we can create a full trial with interactions, with stimuli, with everything, just without just leaving out the things that change, then we can create very, very clear code and stable code, and have all the things that change in a single place. And in fact, what we do is have a set of trials. So we have three sets of trials here. One is called congruent, incongruent, and neutral. And what they do is each of these inherits the stimulus trial. It inherits the place where we define all the generic things, and it defines the specific things with text set in data. So, for example, in the congruent set, we have the text set to blue, the color set to blue, and blue key as the correct answer. And incongruent, we have for the text blue, we have the color red, and the correct answer, the red key, because the prompt is to sort the words according to their color and not according to their text. And finally, for the neutral condition, we have the text as XXX and the color blue and the correct response. So this way, when we inherit the stimulus trial, the huge trial with all the interactions, the correct values get dropped directly into this stimulus, and it knows how to behave correctly. Was that clear?
I have a question. Does the order matter? So it seems to me like it would have, like intuitively would have wanted that information at the beginning of the code and not after the interaction. But does it not make a difference whether it comes before or after?
It doesn't make a difference. It's a matter of convenience. I tend to agree with you. I'm not sure. No, I think you're correct. It would make more sense to put it at the top. It doesn't matter. It doesn't matter. For most of these API calls, it doesn't matter. It doesn't matter the order where you put them. For some of them, it does, but that's the exception rather than the rule. So you could have put this at the top, and it would be fine, and I think it would be a lot clearer.
Yeah, so it's not running things in sequential order. It's
no,
kind of like
no,
taking it as a whole. Okay.
Right. The place where you create the sequential order is the sequence. Okay, and the sequence is the only part of this that it really matters what the sequence is. Okay. Again, there are some exceptions, but in general, that's the only place that you should worry about. Okay. So let's go back to the interactions, and let's look at the correct response interaction. So if the input, red key or blue key, equals to the correct property in the stimulus, which, as we've seen before, is also either blue key or red key. So if they're equal, do these things. And if they're not equal, which we'll see in a second, do these other things. So what we want to do is set the score to 1. And this action, what it does is one second, I need to connect myself to the charger. So this adds the value score1 to the trial data. Look it up in the documentation, and we want to log this response. We want to know how long it took to make the response, and then we hide everything and trigger
Right.
the.
So perhaps the log action might be important to indicate that the log action is needed. I mean, trials are not logged by default. In order to send to the server any information from the trial, you need to call the log action. Currently, in the current version of our server, you can do it only once within each trial. In a few months, the next version, you can do it more than once, but currently in each trial, you can call log only once. And pretty much when you call it, the most important thing is that it will send, the current state of the trial, including, for instance, the latency, right? And that, like,
it saves the latency and the various properties of the trial, including the data, the trial data object, which many times holds critical information, such as the score.
Exactly, yeah. So in this case, it also includes the score, and if you want to log that score, which is really just, the accuracy. I mean, you will get whether they're accurate or not using that. So you need to log in this case. I mean, at this time of the trial.
Yeah. Okay. And so when there's a correct response, we want to immediately hide the stimulus, and then trigger the intertrial interval. We'll jump there for a sec. And what we do is remove inputs. We don't want people responding anymore, and trigger the end trial after ITI milliseconds, which we take from the current above. Okay, and then for an incorrect response, we need to do something a bit more complex. We want to respond to a situation where the input is one of blue key or red key, and not, for instance, the beginning of the trial or some other timeout, but the input is not correct. Okay, so this is where it's not correct, and in order not to trigger one of the other events, we need to require it to be either blue key or red key. And then what we do, we set the score to 0, and we log, and we do essentially the same thing that we do in the correct response.
I have a quick question.
Go.
So where is the name of how that score is going to be logged specified, like essentially like the variable name? So this is to log the data, right? So what are we going to call it?
It's arbitrary. You don't need to define it. What happens is that each trial has an object with arbitrary information, and that all that arbitrary information, whatever the researcher decides is in there, gets saved to the server.
Yeah, but I think that in the case of the current server, it does look for score. So from a lab perspective, because he forgot Minno, he's right. You don't need to call it score. But in the current server, if you want it to appear where I think it's the field correct, which we use for the IT, then you need in your Minno task, you need in the data of the trial, you need the property named score, and you will save whether it's correct or not, or whatever code you want in a variable called score in the data. So that's why Ronen is using here the variable score. As I said, in the next version of the dashboard, you would just call it whatever you want, and it would just save it, not in the presentation.
Okay, so Last but not least, what do we do on a timeout? So on a timeout, if you recall, we had at the very beginning, after the fixation, we set a timeout trigger. If that triggers, here's what we do. We set the score to -1, so we know that this wasn't a failed response, rather it was a failure to respond. And we log because we want to save that information. And we trigger the end of the trial. But additionally, we show a timeout message, which yells at the user, "You're not doing this fast enough," essentially. Okay, and if we want, we can clear it before the end of the trial. I think I removed that for this presentation. Yeah, I can't see it here. But that's another thing that you can do. So when putting together this type of interaction, these are this is the basic way of how it works. You create this these string of events that each leads to the next, and sometimes they branch out, and it's fine. They can work in parallel, and it's all great. And you just build it one block after another. Say, okay, this is how the first step works, and you put it in, and you run your you run your task, and you see that the first part of the trial works, and you say, okay, great, let's add another thing, let's add another thing, let's add another thing, and block by block, you build a whole a full interactive experience for your participants. Okay. Okay. So so we saw the interactions and how they work in this trial. We saw how the different types of trials were built. Now I want to take a few minutes to look at the sequence. And the sequence in this case is rather simple. We have an instruction trial at the beginning and at the end, which are built. Where are the instruction trials? Okay, so this is a generic instruction trial, and here are two instruction trials that extended. And again, they use the instructions that are set at the top in current, which is very useful as a central place where you can change the way that the task behaves. I really like this style of programming because when you want to make changes, all you have to do is play around in this part, and everything works, which is rather cool. Unless you want to change the way the task itself works, but if you want to reuse the task, all you have to do is come back to this part, and you're good. Okay, so we have at the beginning of and the end, we have these instruction trials, and in the middle, we have a pair of mixers. So I think I overed this a bit, which is fine. So this should be 12. That's it. So mixers work from the inside out when they're listed. So the first mixer that gets activated is this one. And what it does is repeat this subsequence 4 times. And then we have, theoretically, we have a sequence that has congruent, incongruent, neutral, congruent, incongruent, neutral, congruent, incongruent, neutral, congruent, incongruent, neutral. Very, very much ordered. And then it's nested within a random mixer, which randomizes the order of each of these trials. So far, so good. Now, what we want to do is make sure that the different the different stimuli within each set appear the correct number of times. And the way we do that is by the way we do that is by using an inheritance type called equal distribution, which makes sure that each we tell it how many trials overall we have, and make sure that that each trial within the set appears the same number of times within the within a set of 4, for example. So we're repeating each of these trials 4 times. So we need n equals 4. This is a very specific type of randomization. So if you need something of the sort, look it up in the documentation. It's all there. And what's the time? Okay, so this randomization gives us gives us the full randomization of order, and this randomization allows us to make sure that each specific stimulus appears the same number of times. Okay, and that gives us the randomization conditions that we required at the beginning. Okay, so is there any other? I think we went over most of this script. Are there any questions about this script? Any part of it that you want me to go back to or explain? Okay, so I think I think that's it for tonight, or today for you, I guess.